Hello, everybody, and welcome to Silence Abounds Science at Home, where we will discover home lab magic. In this channel, we will perform experiments demonstrating scientific concepts, principles, and reactions in chemistry, biology, microbiology, microscopy, and molecular biology. Welcome to my channel. Hello, everybody. Welcome back for another episode of Silence Abounds Science at Home, where we will discover home lab magic. In today's video, we're going to demonstrate two reactions that produce gases as a product. The first reaction we're going to look at is hydrogen, is the production of hydrogen gas. And then the second reaction, we're going to demonstrate the formation of chlorine gas. And we're actually going to use MEL Science kits. These are phenomenal kits that you can buy by subscription. You get monthly delivery of kits containing 2 or 3 different experiments, and there's usually enough in the kit to do each experiment at least twice. And this is a great way to bring science into your home. And they do chemistry, they do some physics kits and medicine kits as well. And I highly recommend them if you want to do chemistry experiments in your own home. They're a fun, easy, safe way to do chemistry experiments. So please do check them out. They are by subscription only. You can't buy them individual kits at the moment, but highly recommend them. So today's reaction, the first reaction we're going to look at is the production of hydrogen gas. And the reaction we're going to do is the reaction between zinc and sodium hydrogen sulfate. The reaction between these two leads to the formation of hydrogen gas through a redox reaction. The overall reaction can be written as follows. Zinc is a more reactive metal and can displace hydrogen ions from acid or acid salts like sodium hydrogen sulfate. The hydrogen ions from sodium hydrogen sulfate are reduced, forming hydrogen gas. Zinc, being oxidized, forms zinc ions and reacts with the sulfate ions to form zinc sulfate. Zinc atoms lose 2 electrons to become zinc ions, and the hydrogen ions gain electrons, i.e. reduction, to form hydrogen gas. So let's perform the first reaction and produce hydrogen gas. Okay, first things first is we need a beaker and we need to pour in some liquid soap. What we're going to do is, how do we know hydrogen is being produced? Well, the simple way is to bubble the gas into liquid soap to make bubbles that we can ignite with a flame because hydrogen will burn. So it's an exciting reaction to watch, and that's how we're going to demonstrate this reaction. And so I'm going to add about 10 drops or more of liquid soap. Hopefully I've got enough. Oops. Okay, it's not. Okay, and next what I'm going to do is I'm going to add about 10 drops of glycerol. And then about 10 drops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 drops. And then I'm going to add 75 mils of water. So okay, 75 mils of water. I'm going to put that into the beaker. Like so. And I'm going to just give that a little mix like so. And the next phase of the reaction is putting my babbler together. So I've got a conical flask with a rubber stopper. And what I'm going to do is the reaction is going to take place in the conical flask. And I'm going to bubble the gas, the hydrogen gas, into our soap solution. So first of all is I'm going to add the sodium hydrogen sulfate into the conical flask, and I need to empty the bottle. So it's kind of crystallized because it's hygroscopic. It attracts water. So I'm going to try and crunch out the chemical. Okay, this is not going to work. Let me just soften it up. Okay, I've got most of it out now, so excuse the noise. So next is we're going to add the zinc. We need a bottle of zinc. So with MEL Science, they give you the exact amount of reagent that you need for each experiment. Okay, so now I'm going to pour this into the conical flask. That is also solidified. So it kind of okay. And in goes the zinc. All right, so the zinc has been added. And what I want to do now is I want to add 60 mils of water into the conical flask. Okay, and then I'm going to put my rubber stopper in, like so, and I'm going to bubble this. As the reaction starts, it should start bubbling, and I'm going to give the flask a mix. So the reaction is starting already. Bubbles are beginning to form. Oh, did you hear that? So that was the hydrogen reacting with a loud pop. The reaction is still going on, so I'm going to make some more bubbles. And let's see if I can make that pop again. Okay, the gas is still being produced, so let me try again. Do it another time. You can see the gas formation being produced in the conical flask, and I'm bubbling that gas formation, the hydrogen gas, into my soap solution where the bubbles are made. Oh, that was a louder bang this time. So I'm getting a lot more gas being produced. Well, I hope you enjoyed that little demonstration of a reaction between zinc and sodium hydrogen sulfate to produce hydrogen gas. So the second part of the video, we're going to look at the generation of chlorine gas. Now, when sodium chloride reacts with sodium hydrogen sulfate, the reaction produces hydrogen chloride gas, or HCl, and sodium bisulfate. The sodium hydrogen sulfate produces the hydrogen ions necessary to drive the displacement of chlorine from sodium chloride. After hydrogen chloride gas has been produced, it reacts with manganese dioxide. The manganese dioxide acts as a catalyst of the reaction, helping to oxidize the hydrogen chloride gas to chlorine gas. The manganese dioxide is reduced to manganese 2 oxide. Chlorine can oxidize iodine in a displacement reaction, and this occurs because chlorine is a stronger oxidizing agent than iodine. And this is how we're going to demonstrate in the formation of chlorine from this reaction. We're going to look at the color formation of from the oxidizing of iodine from chlorine. And so let's now do the experiment. For this reaction, I need to set up this little burner that I have, and I'm just using candles as the formation of heat, as my heat source, like so. Okay. And then what I want to do is, before I light that, is I want the bottle of manganese oxide, which I should have dropped. So I got the manganese oxide here, and then what I want to do to that is I want to add the sodium chloride, which I have here. So I'm going to open the bottle. Okay. Okay. So what I want to do is I want to empty the whole contents of the sodium chloride into my container of manganese dioxide, like so. And then I want to shake it for about 1 minute. Okay, that should be enough. So now what I want to do is I want to add 2 big scoops of that mixture into a beaker. Get my scooper. So I want 2 scoops of that mixture into the beaker. Okay, 1 and 2. Okay. Next, I want to add 2 big spoonfuls of the sodium hydrogen sulfate, which I have here. And remember, it's very hygroscopic, so I'm going to have to try and get this out somehow. Okay, so I want 2 spoonfuls of that. Let me see if I can pour it out. Yep. Okay, 1. And then another spoonful. Okay, I've got 2 spoonfuls of the sodium hydrogen sulfate. And next is I want to add 3 mLs of water. So I have a syringe for that. So I'm just going to suck up 3 mLs of water, like so. I'm going to add to the beaker, give that a mix. And then I'm going to get a filter paper. And then on the filter paper, I'm going to add a drop of thymol blue pH indicator solution. And I'll tell you what that is for. This is another way of indicating the presence of chlorine. So just 1 drop, and then I'm going to add 1 drop of potassium iodide to the other half. Okay. So I'm going to put 2 drops. So right now it's colorless, as you can see. The thymol blue is blue. And now I'm going to get the burner ready, because this reaction works faster if heat is included. So let me light the candles. Okay, we've done that. And then we're going to put the platform on. And then we're going to put the beaker of the mixture, and we're going to watch what happens. So it takes a little bit of time. So like I said, chlorine, potassium iodide and chlorine displaces the iodine, producing a deep brown color. So this colorless spot here, if chlorine is being produced, should turn brown. The pH indicator, thymol blue, changes its color from blue to orange because the chlorine dissolves in the drop of indicator and forms some acid. Chlorine can oxidize the molecular iodine further, leading to colorless substances are formed. And in this process, this is turning brown very slowly, as you can see. And if you keep going, it should actually go back to being colorless. So as you can see, the thymol blue has turned orange. And this will actually become colorless. Both of them will go back to being colorless because the thymol blue is oxidized by the chlorine. So there's quite some chlorine gas being produced here. And let's just carry on cooking and to see whether these two spots go colorless. So this test has proven the presence of chlorine. We've got a deep brown color of the iodine, and then the thiamine has turned orange. So they should, in theory, go colorless. We'll see if that happens or not. So as you can see, the iodine spot is going colorless here, and the orange, the thiamine blue, is also losing its orange color because the chlorine is oxidizing the iodine further into colorless substances. Well, I hope you enjoyed those two demonstrations of fundamentally important reactions, very simple reactions on how they can produce two different gases, hydrogen gas and chlorine gas, as a product of the reaction, and a demonstration on how we can indicate and prove the presence of those gases. Please, I hope you enjoyed the video. Hit the subscribe button. It shows me great support and keeps the channel going. I've made lots and lots of future videos with many interesting experiments are coming your way. Please also hit the like button, the share button. Also, send me an email. Send me your questions, your comments, anything you want to talk about or ask about science or the channel. Please also send me your photos and videos of you doing home lab experiments. Please check out my link to the video because I list all my resources that I use in order to perform all these experiments in my home lab. With that, until next time, keep on experimenting. Goodbye, everybody.